Welcome to the Quick Start video for Process Simulator. In this tutorial, we'll show you how to build a quick little model and help you get started using the software. Simulation modeling is normally used to predict the performance of complex systems. However, in this Quick Start video, we'll look at a very simple system. Process Simulator and ProModel both use the same simulation engine. However, Process Simulator works as a plug-in inside of Visio, so its features and its user interface look a little different than ProModel. However, Process Simulator and ProModel are both full-featured discrete event simulation modeling tools. Now let's open Process Simulator from our desktop shortcut. The first thing that you'll see is a Getting Started window. And this has 6 clickable buttons that will take you to other resources. For example, demo models that you could run since they're already installed on your PC. For now, I'll close the Getting Started window and we'll look at the menu ribbon. Across the top, we'll see menu ribbons for Visio because Process Simulator again is a plugin working inside of Visio. To the right is the Process Simulator 2019 menu ribbon. The way that Visio works is you select one of the icons in one of the stencils open to the left. Then you can drag it over using your left-click mouse button into the layout area. Now you can Control-C and Control-V copy-paste that shape multiple times, or you could bring in more icon shapes from the stencils that are open to the left. Now a third way to get shapes in here is to use the Auto Connect feature. Auto Connect will highlight 4 small blue triangles around the shape that you're hovering over. Then if you slide your mouse over one of those triangles, it will give you several icons to choose from. If you select one of those, it places the shape and it connects it to the previous one. Now that I've reviewed how Visio works, I'm going to delete these items and let's build a model with just 2 activities. First, I'll go over to my Process Simulator stencil and I'll select the General Activity box. Next, I'll use the Auto Connect feature and hover over this blue triangle to the right, and I'll select another blue activity box. Let me zoom in just a bit. Now I need something to flow through the 2 activities in my model, so I'm going to go back to the stencil and select an entity. We'll select this work unit entity right here. Since I used Auto Connect, the connection between activity and activity 2 has already been made. However, I need to make a connection between work unit and activity. So I'm going to the Visio Home ribbon and I'm going to activate the connector tool. This will allow me to hover over any shape, left click and drag to the middle of another to create my own arrow. And I'll put one here at the end of activity 2, just going off into the layout in order to create an exit routing. Now that my connections are done, I'm going to go back to the pointer tool because it's just an easier tool to use when moving about inside of Visio. Since we used shapes from the Process Simulator stencil that already has assigned simulation properties, and since we've connected them all, we actually right now have a working model. I can click on the green Simulate Diagram button and the model begins to animate. I'll click on Zoom to Fit. You'll notice the entity shapes are moving from one activity to the other and then through the exit. On screen, we can see that the total number of exits is changing dynamically as the model runs, and we also see the average cycle time in minutes. You may notice some small numbers above each activity shape. These are default input buffers, and so what we're seeing the effect of is work unit entities are arriving into this activity. However, each activity capacity is only 1 by default, so the other entities have to sit in the buffer and wait their turn. You also may notice up in the top right-hand corner, there's a simulation clock. Right now this model has been running for over 6 hours. I can speed up the animation by left-clicking on this little animation bar, or I can slow it way down. If I pull it all the way to the right, then the model will run a default of 40 hours. And we could immediately go see some results. We'll look at some results later. Right now, let's go back and look at the model and look at some of the properties of these shapes. To look at the properties of any model element, first left-click on it to select it. Then right-click and go to the word Properties. For the work unit entity, there are only a few values to look at. However, if we click on the arrow with the hollow arrowhead, this is a special arrival arrow that connects the work unit entity to the activity. And arrivals can be multiple types: continuous, scheduled, ordered, pattern. However, the default is periodic. That means periodically a quantity of one entity will show up every 5 minutes. And the first start time of the first entity arrival is at 5 minutes. These values are set for you by Process Simulator as a default. However, again, you can change the arrival type to a different one. If we continue over to the right, we can look at the properties for the activity. Here we see the activity capacity as well as the size of the input and output buffers. All of these fields are editable and can be easily changed. We also notice the time field. Right now, the activity will take anywhere from 3, 5, or 10 minutes for an entity to go through here. This is called a triangular distribution, and it uses the minimum of 3 and the maximum of 10. However, most of the time the entities will stay here around 5 minutes. There are other options and categories for every activity below. We could designate a resource to perform this activity time. We could set its availability. We can even do batching, setup, downtimes, and other values if they are appropriate for this particular step. And every one of these shapes, except for the entities, also has a logic window. So for activities, routings, and even arrivals, you can add logic. If we click on the arrow connecting activity to activity 2, this is a typical route arrow. And right now, it has a move time of 1 minute. Again, this is just the default move time and it can be easily changed. The routing arrows are not to be ignored because these are important transportation steps. Oftentimes, moving an entity from one place to another could happen very quickly. However, this could represent the movement of the entity using a forklift or a person or even a truck that might take a day or two to get there. So routings can have logic, and routings can be different types as well. This particular routing is a percentage type. However, there are a total of 8 different types of routings that are available. So in this simple system model, 100% of the time, the entities will move from activity to activity 2 and take 1 minute to get there. Activity 2 has the same default properties that we saw in the first activity box. However, again, all of these are editable and changeable. So in this simple model, if I go to the activity, I could change this triangular distribution to just be an even 5 minutes. Then activity 2, I could do the same thing, 5 minutes there. So if activity 1 is 5 minutes and the routing is 1 minute, plus another 5 minutes, then the total time for our system is just 11 minutes. We could calculate this on a spreadsheet, easily predict the throughput if the times were all that even. Then why do we use simulation models? We use small models like this because in the real world, oftentimes the actual processing times vary tremendously. And also when we introduce people or equipment breakdowns or break times and other interdependent factors, we will see variation in model results. So models can help us predict what's going to happen in the future by modeling what's happening today in the current system. Now we'll simulate the model and look at some results. Then I'll make a couple of changes and we'll come back and see how the results change. I'll zoom to fit, and this time I'm just going to turn the animation off by clicking the animation button. The model runs very quickly and immediately we can see the results. The output viewer gathers lots of data automatically behind the scenes, and you can even designate your own metrics, your own variables to collect additional data. Right now we can see that we had 477 exits and their average time in system is always 11 minutes because we have a perfectly even system, 5 plus 1 plus 5. So let's close the output viewer and make a couple of changes, and we'll do this by building a scenario. I'll add a scenario where we change the activity times. For the first activity, we'll use a uniform distribution of around 5 minutes, but a half range of 1. For the second activity, we'll use another uniform distribution around 5 minutes with a half range of 2. Think of half ranges as being plus or minus. So this would be anywhere from 4 to 6. This would be anywhere from 3 to 7. So now I'm going to run just this scenario by itself. We already have data from the first model run, which we'll call the baseline. I can see up in the corner that I'm running scenario 1. I'll turn the animation off, and now again we can look at the results. We still have the baseline model results, and now we also have the results for scenario 1. And if I compare the two side by side, I can see tremendous difference in the average time in system. And the only thing that we changed was some of the processing time for each activity. We just introduced a little variation. The other thing I noticed here is the tremendous amount of blockage that's occurring to the work unit in scenario 1. So this is occurring because of that variation in the processing time. It means that the single capacity is not enough, and many of the entities are blocked and having to wait even longer. And that's reflected in the long average time in system. So again, this was just a demonstration of a simple process model. However, we could make this much more complex. We could add more resources, activities, downtimes, setup times, and business rules in model logic. So simulation tools like this help us to study process behavior, answer what-if questions by changing some of the individual model element properties. We can also test whether proposed changes will be effective in a process and even determine the optimum settings. If you'd like more information about Process Simulator, then you may want to view the longer tutorial available on our website, or feel free to contact us. Thanks for watching.